Hi guys. Today I'm going to talk about properties of exponents, and so let's get started and check these out. There are three properties of exponents I'm going to look at today. There are actually several more that we'll hit in another video, but today I'm going to talk about what happens if you have a negative exponent, or if you have variables that are multiplied together and also divided. What do we do with that? And so let's look at the rule and then look at some of the examples that I have up here and see if they make sense to you. The negative exponent, first of all, exponent is the number that is up on the upper right hand side. If there's not one there, then it's implied that it would be 1. So like a number like 2 would just be written as 2, but it would actually have a power or an exponent of 1. So just remember that. But what happens if that exponent is negative? Well, you can rewrite that by following this rule right here with a positive exponent by taking that 1 over top of x to the positive n. So if I have x to the negative n, it's the same as 1 over x to the positive n. Now here's an example right here. I have 3 times x to the negative 2. Well, only the x has a negative exponent. 3 has a positive 1 exponent. So I want to handle that negative by using this rule. Well, and I'm just going to cover up that 3 for a second. Since x to the negative 2 would be 1 over x to the positive 2, this problem becomes 3 times 1 over x squared. Now, if you happen to have a number a whole number multiplied by a fraction, you can think of that whole number as something over top of 1. So this answer, or another way of writing this, would be the same as putting the 3 over top of x squared. That probably would be the best way to write that. Now, if it happens to have a negative exponent in the denominator, what's kind of neat about this is when you apply this rule, it would be 3 divided by 1 over x squared, like we have that, which really just means that you would move the negative value, or the negative exponent, to the top and make it positive. So let's see if you understand what I was trying to say here. If I have 3 over top of x to the negative 2, this is going to be the same as 3 times x to the positive 2 over top of 1. And so what I'm showing here is this. If the variable is in the denominator and it's negative, you can move it to the numerator and make it positive. If it's in the numerator and it's negative, you can move it to the denominator and make it positive. So that's kind of a little shortcut to that. Another type of property that we're going to look at today is something that's called the product of powers. Now, we've probably used this occasionally already, such as whenever we multiply x times x, we'd get x squared. That's because we're really using this power property, or product of power property. And the rule looks like this. If I have x to the n times x to the m, I just add the n and the m together. So in this example, I have x to the 6 times x to the 4. Well, I just add 6 plus 4, and that would give me 10. So that answer would become x to the 10. Keep in mind that if you happen to have something like that would have a number associated to it, like this 3x squared y times 2x cubed y squared, you just multiply the numbers together, such as 3 and 2, the coefficients. That would give you 6. And then you add your exponents together. Here I have x squared, and there I have x cubed, so I would add 2 and 3 and get 5. So I have 6x to the 5th. And there I have a y to the 1 and a y to the 2. If I add 1 and 2, I get 3. And so here I would end up with 6x to the 5th, y to the 3rd. that property is kind of the opposite of the next one. This one's called quotient of powers property, and that's if you have two like variables or like bases and they're being divided. And if I have x to the n divided by x to the m, I do the opposite of what I did up there. I'm going to subtract these. I'm going to take the power on top minus the power on the bottom. So here's an example. If I have x to the 12 over top of x to the 8, I'm going to subtract 12 minus 8. So if I take 12 minus 8, I get 4. And so there I end up with x to the 4. Over here I have a little more elaborate situation. Here I have 8 x to the third y squared, and over top of 4 x to the 2 y to the 6th. Now, if I keep in mind that I divide these numbers or reduce them, if they're a fraction that will reduce, and this will, 8 over 4 would be 2, so I put the 2 in the top. So I have 2 up there, and if I follow this rule, I have x to the third on top and x to the second on bottom, so I'd subtract those and I'd get x to the 1. So you get x to the 1. Now, if you look at the y's, I have 2 y's up top there. I have y to the second on top, and I have y to the 6th on the bottom. In other words, there's more y's in the denominator than in the numerator. That wasn't the case with the x's. We had more in the numerator than the denominator. If I apply this rule of 2 minus 6, do the subtraction rule, I get negative 4 as my exponent. And I really don't like to have negative exponents. So another way to use this rule and keep positive exponents is just to subtract, but cancel as you go. In other words, if I cancel these 2 y's on the top with 2 of these 6 in the bottom, I'd be left with 4 on the bottom. I really am subtracting. So, 6 minus 2 would be 4. So, and so sometimes I like to teach my students how to do this by just canceling. You really are subtracting. So I cancel out 2 of the top with 2 of those 6 on the bottom, but that leaves me with 4 in the denominator. And so this answer here becomes 2x divided by y to the 4th power. So, well, that's how you use those 3 properties, and I'm going to be back a little bit later with a few more of them. So we'll be adding to this. I hope these help you, and thanks for coming by.